association, I thought it would be a good opportunity to share how we have understood Industry 4.0, Industry 4.0, as we call it, and the journey towards that, smart factories and cybersecurity. So, without much ado, the agenda is around, I will also take a few minutes to explain digitalization, which also is one of the aspects Siemens is talking about nowadays, and I think it was important for me to put the context. And of course, we'll go through the German Industry 4.0 initiative, and also give you a dimension of how an organization like Siemens is responding to it in a few minutes, and also a few dimensions about how this initiative is manifesting itself, say, in Asia and in the US, so that it just lays a context to the whole, and it's a good segue to our panel, which is going to go into the depths about cybersecurity in the industrial Internet of Things. So, as I told you and I promised you, I would take a few minutes on this word digitalization. I'm sure it sounds familiar, but the fact is there is no word like digitalization that existed in the dictionary, even probably now. But there was a need to create it. And I think it's very important to understand this difference of what digitalization means in context to what digitization is all about. And I think what you're seeing here will probably give you more context later on. You're seeing a lot of connected physical equipments, whether it's trains or medical equipments or industrial assets. On this side, you're seeing everything virtual, which is about data and information and knowledge and stuff like that. And I think everybody is familiar about that, and everybody is familiar about this bar, and we will come to that later. So I think on the fundamental side, digitization, and digital is about storing information and data in digital form, which is ones and zeros, as you see. And digitizing was about the process to do that. How do you convert sound signal to digital, or electrical signal to digital? I think this is what was capturing everybody's imagination, and the effort was all about efficiency, and I would say fidelity, quality. This was the need, I guess. Yeah. There were some challenges to start with computing power not being sufficient, but all that got solved. But as we move forward, I assume all of you have seen this evolution that apart from quality, another thing that has come up in this act of digitization or digital things, convergence. The fact that almost all data that is converted to digital form converges into a common medium. And then on the top of it comes the possibility to correlate the analytics and other kind of stuff. So I presume you're able to see the journey of what was initially started off as something to convert for efficiency, operational effectiveness. Today it's got a different dimension. I like this example from the B2C market where making an ebook is probably digitizing, but giving a different user experience with the same all the economy of scales you have, but giving a different user experience will become digitalization. It's about how you change the customer business models and other kind of stuff. So over the years, what has really happened is, over the last 5 years actually, is that this convergence has come and there has just been a different dimension of the opportunities that it is offering to the business. And I think this is very important to understand when we say, okay, a company that is very digital would look at automating its processes to make the business more efficient. In contrast, a company that is looking at digitalization would look at utilizing these processes for more, to get a better outcome out of these processes by better customer engagement and different business models and different plays. So this is the dimension that I wanted to say, and there is going to be a lot of blurring of this line of using these both in continuum, and that's what is the cyber-physical world topic coming up, and that's all that is probably manifesting into digitalization. So Siemens talks about in 2020 to be very active in digitalization, and I presume many companies are talking about digitalization, and I just wanted to bring in this dimension of the difference that is between being digital and then being digital and going for digitalization. Having relate the context, if you look at digitalization and Industry 4.0, digitalization of the manufacturing industry is a worldwide topic. It doesn't belong to Germany alone. It's a worldwide topic. Everybody is talking about digitalization. And the fundamental discussion is on the future of this industry and how we are able to, and the challenges being faced. I think broadly, the challenges that are being looked at now is about reducing the time to market. It's about enhancing flexibility and increasing efficiency. You see the dimensions are different, and it's also, it's to create new business opportunities for these organizations engaged in this process. And at all times, keeping safety and security in paramount importance. And of course, there are various initiatives underway to address this. The German government's initiative of Industry 4.0 is directly, looking towards smart manufacturing and the manufacturing industry. There is a broader initiative in the US, which is Industry Internet Consortium, which actually is not restricted to manufacturing alone. It talks about everything that needs, every other industry also, including IoT itself. So these are small paradigm shifts, but German Industries 4.0 is focused mainly on the manufacturing industry. And this is a slide that just goes a little bit deeper to explain the context. It's the cornerstones of the initiative of Industry 4.0. It's a key research area of the German industry sponsored by the German government. So the German government has taken leadership here to create what I would call this pre-competitive coalition of how do you get forward on this areas, and looking at 3 concrete steps, which is about horizontal integration of the value-added networks, vertical integration and network production systems, and end-to-end engineering across the entire value chain. That sounds very technical, right? So these are obviously in dimensions about how you want to expand in all directions the powers of what we saw about digitalization to create better business outcomes that we saw in the previous slide. Understanding that this is not so easy to digest what is horizontal integration and vertical integration and end-to-end engineering, I'm just going to be using the kind of representation that we used in engineers' language of what we think things will be moving towards, yeah? Or maybe most of it is already there. So you will have, this is a kind of a, looking forward of how a manufacturing assembly line could look like in a car manufacturing plant. So you have a car body and it says, I will tell you what's next. You have a robot 2 and 3 that says we need special parts. We have a robot, a convoy which says I want to go into energy saving mode because there's not much going to happen in the next few minutes. You have a robot that says I need to be repaired because I have an issue coming up. And last but not the least, you have this very important man who's still there, but with probably more time to deliver what he's good at. Yeah? Basically, it's about seeing what is real time going on and actually doing what a man is good at. And taking a good analogy is, look at what happens in hospitals these days. A nurse goes to a patient, you have a, kind of a nurse call sheet that can be easily digitized into having an iPad there. Yeah? But extending it to digitalization would be about that taking all the monitoring and doing the alarms, and the nurse actually doing what they're supposed to be good at, which is about personal care, which is about the touch and the care that is really needed from a human that cannot be replicated by a robot. Yeah? So I presume this scenario is already almost there, but this is how the future manufacturing is going to be. It's about a lot of interactions, it's a lot of communication, and the man is freed up to do more value-added stuff. And in this journey, you're also going to see a lot of new business models coming up, even for automotive manufacturers and others that they can leverage on. Yeah? So it's clear that only a holistic approach can actually take you towards this journey, which involves product design, planning, engineering, execution, and service, and you have the value chain linked to all this. So the way Siemens is addressing it today is precisely by looking at all these dimensions that are required between these 2 things, the physical world and the virtual world, as we call it. We of course, we are looking at manufacturing, so we talk of process and discrete industry. We have a set of tools that address many of the dimensions that are required during the planning phase, which seamlessly integrates into what we call production and the service phase, and creating what I would call this data, democratization of data, yeah, which is having a platform that you can seamlessly share data and work on it. So all these are initiatives that are stepping to it. We are not fully completely there, but we have offerings that are leading to it, and we call it the digital enterprise from our side. And obviously, and here's just an example of talking about the digital twins. It's about digital connectivity of digital thread and insight from lifecycle analytics. So these are all dimensions that we are addressing towards digitalization and the industrial Internet of Things. And security, of course, being the cornerstone, very important and relevant. And this last slides in terms of what we are doing with SAP. So on the services side, which is basically on the lifecycle services, we're talking about innumerable industrial assets that need to communicate. The data needs to be handled, and you need to be able to seamlessly work on this with advanced insights and other kind of applications. And here is where two German organizations, Siemens and SAP, have partnered. SAP has we are using their SAP HANA technology in our what we call the Siemens Plant Cloud, which we have branded as MindSphere, which basically is about getting this industrial connectivity on and enabling our end users and the OEMs who are using to be able to utilize the power of correlation and connectivity and convergence, as we call it. Yeah. So this is just a short perspective about how we also believe we can't do it alone. Neither in security nor in IoT, you need partners, you need engagement, you need collaboration. There's no way one organization alone is able to really achieve what is required. This is a very dense slide, but I just put together that every country is talking about it. You have Germany, which is talking about Industry 4.0, and there are special projects on autonomics, production technologies, smart data, smart services, IT security. These are all topics that are driven under the work streams of, I'm sure, a colleague from Teletrust will be able to talk a little bit more about what is going on there. We have on the US several initiatives going on, even NEMA, which is an industrial association here, now talking about an IoT work stream and a cyber work stream on IoT, on which I am also in the board. We have India and China speaking very aggressively about, of course, how they're going to reshape their manufacturing and prepare it for the future, which needs the cornerstones of what we are all talking about, the industrial Internet of Things, addressing the enablement and adoption of these things. So this was a short presentation I created for giving a backdrop about our understanding of Industry 4.0, the fact that you have similar initiatives going on, which is in the US, which is the Industry Internet Consortium, the Internet of Things. I think all of them are driving towards creating more awareness, creating more constructive collaborations in this field. So that's about what I had to speak, and now I would probably jump into the panel. Yeah. Good. So I was very much humbled when I had this chance to moderate this esteemed panel. I mean, when I went through the profile, I think the knowledge this panel can share, and I guess what you all have come here to hear about what is the current status and where we're going forward and the challenges, I presume I would request each of the panelists to actually do their introduction, because I would be doing no justice in introducing the panelists myself. But only a few, logistics. One is, of course, we are going to be focusing a lot on industrial Internet of Things, just to keep the topic focused more on this dimension, because IoT is a very broad topic. So I would also, along with the introduction, request the panelists to speak the individual perspectives as to how evolved the cybersecurity practices in the industrial Internet of Things, in the manufacturing and in the related space. What have been the developments and what are the challenges? So it would be good to set stage with an introduction and your perspectives. Yeah.
Yeah. Ladies and gentlemen, my name is Norbert Pohlmann. I'm professor in the Computer Science Department for Distributed Systems and Information Security, and I'm director of the Institute for Internet Security at the University of Applied-Gelsenkirchen. And additional to that, I'm chairman of the IT Security Association Teletrust and member of the board of the ECO Association. And at the university in Germany, we have different research focuses. It's cyber early warning systems, cyber situation awareness, internet key figure systems, and trusted IT solution. And additionally, we do research in the botnet detection, the mobile security, and identity management, and modern authentication systems. I would like to start with an estimation about the IT security situation at the moment. If you see in general view of the IT security situation, I have to say the IT and IT security technology which we use at the moment are not secure and trustworthy enough. We you all know the problem. It's inadequate software quality. It's insufficient protection for malware. It's insecure web server. Or we still use passwords for the authentication in the internet. And all this, because of all these problems, we see very successful professional hackers. And the result is that the risk is increasing and the damage too. And I think that is the biggest problem we have to face at the modern society. If you see the situation today, I think it's the same situation for the normal and for the industrial internet. So what we really need is more secure and trustworthy solutions, and that alone is a huge challenge which we could not solve until today. And if you see a concrete view to the IT security situation for the industrial internet, it could say, one idea is that attacks on critical infrastructure have a high potential for much more vulnerability for our society. And we have to see that with the industrial internet, this will be much more part of our critical infrastructure. And we have learned with Stuxnet that political goal can be implemented very easy and cheap at the cost of $9 million. With Stuxnet, it was possible to delay the Iranian processing in Iran for 2 years. And if you see the terrible alternative of this political goals, then maybe 200,000 Western soldiers would have invaded Iran, and that will have cost more than some billion US dollar, and also people would have been died. So we really have to see the damage, or we really have to see the problem which comes with the cyber war idea. So we have altogether to make sure that our critical infrastructure have to be secure and resistant enough to this cyber war. And that is what we really need is very, very new ideas. How can we build up security systems, and how can we secure our industrial internet? And I think we really need new ideas to make our future much more secure.
Thank you. Thank you, Norbert. Donna.
So good afternoon. I'm Donna Dodson. I'm the Chief Cybersecurity Advisor for, can you hear me in the back? No? Is that better? Yes. Very good. Thank you all. I'm Donna Dodson. I'm the Chief Cybersecurity Advisor at the National Institute of Standards and Technology. We are an agency under the U.S. Department of Commerce. So within the U.S. government, we are a non-regulatory agency, and our role across NIST is really in the development of standards and metrics in a wide variety of areas, including information technology and in my world, in cybersecurity. We have a research and development program that's been around since the days of what we used to call computer security, and then changed over time to information security and information assurance, and today is called cybersecurity. In addition to that, we have a number of new initiatives that we've started over the last 5 or 6 years, which really takes a look at how we develop, not just develop standards and best practices that can be used, but really taking a look at the details on how you can engineer them out to give people additional guidelines on how to do that. So our program has expanded from the traditional research in places in areas such as cryptography and key management and identity management, as vulnerability management and security automation, to looking at ways to have stronger identity management across the digital infrastructure that really takes a look at security, interoperability, usability, making it easier to do the right thing, harder to do the wrong thing, and easier to back up if you do the wrong thing. Taking a look at privacy as well, and how we do this in a way in the United States which is really driven by the private sector rather than the U.S. government. In addition to that, we're very active with the National Initiative for Cybersecurity Education. How do we get additional people into the workplace, making sure that they have the skills and technical capabilities that they should have? And once they're in the workplace, how do you manage training for them for new areas, such as the Internet of Things, or for us more broadly, cyber-physical systems? We recently established our National Cybersecurity Center of Excellence and have some great partners like Symantec and others at our center. How do you take standards and best practices and understand what the business concern is about implementing them, starting with that business challenge first, and then getting down into the technology aspects, looking across at a risk management approach and the necessary cybersecurity controls. But, you know, cybersecurity people are really good at talking to cybersecurity people, but we're not always so good at being able to have those important conversations with businesses and other organizations, and that's really where the cybersecurity needs to start. So we've had another important activity through an executive order from the President of the United States to take a look at improving critical infrastructure cybersecurity. And we produced a framework based on standards and best practices to help improve critical infrastructure cybersecurity across the United States. It's all voluntary, but it really isn't U.S. specific. It builds on international standards because those standards give us a platform to create innovation. And I think that's something that's very important in the space of IoT. I think we really have an opportunity here as we're building more capabilities today to think about how to engineer security into these systems. But we need things from a standards perspective. Just what does IoT mean? And my guess would be if we handed out a piece of paper and we asked people to write down their definition of the Internet of Things, of cyber-physical systems, of operational technology, we would come up with a lot of variations there. And so those kinds of standards help create that dialogue so that we can understand what we're all talking about. We can understand what the security needs may be, because when you think about IoT, when you think about cyber-physical systems, perhaps confidentiality is not the greatest need. Perhaps it is availability. Or in many cases, when you think about sensor networks, whether they're in automobiles or along the side of the road or giving us weather data, the integrity of that information may be much more important than anything else that we do. So we need to continue to have these kinds of conversations. NIST actually has a cyber-physical systems program, and it's a community program where we have participation really from all around the world, looking at different aspects of cyber physical systems, including security. In addition to that, we have a big program on developing smart cities and what that can mean. And again, these all have an international emphasis to them because we do have a global marketplace. And as we think about the digital economy, not just of one nation, but of all nations, we have to work together to get those platforms in place.
Yeah, thanks, Donna. I think there's a lot of substance in what you said, and I think we're going to take a bit of cues later on in the session to make provoke you on some topics. So, Brian.
Sure, thank you. I've spent most of the past 20 years helping build security into countless kinds of systems. Military systems, manufacturing systems, train control systems, power grids, both the teeny little embedded devices that have extremely limited computing power and big distributed systems, often of millions and tens of millions of these nodes. And one of the really common patterns that I've seen is people often think that they can add just one little bit of security and call it good, as if putting one leg under one corner of a table would somehow hold the table up. And the reality is you need to protect the communications, protect the devices themselves, manage the devices because security is never done, and then you need a security analytics framework to look for those really sophisticated adversaries that can overcome those first three cornerstones. And as we build these systems, it's not enough to just deploy more technology. Often I see just one or two pieces salted in and all of the other doors and windows left wide open. And the consequences of that cause me concern as I look at a lot of manufacturing systems, power grids, other critical infrastructure moving forward. But at the same time, in the long term, I'm also optimistic because as we build in security, as we do it right, it's possible to get security right in a way that depends a lot less on these end users. They can't even remember their passwords like me. And so in that case, I'm both worried in the short term and optimistic in the long term.
Thank you. Hello, good afternoon. My name is Jörg Borchert, representing Infineon Technologies, who is a semiconductor company, and I'm representing the security part of the business. So I've been in this area since '98 here in the United States. And for us, when the thing came up, Internet of Things, the most important part was to create standards. Standards in the very early beginning. We have been active since 2000 in the Trusted Computing Group, where I'm right now the president and chairman. And secondly, engagement in the early part of the industry internet consortium, and where we actively drove these standards regarding security together with 17 other companies. 3 of them from Europe, so sometimes it's perceived as an American exercise, which it's not. And here we are developing use cases and as well as attack vectors, which we have to counter. So standards are a really important part, on one hand, to have an early understanding what the challenges are. And this requires sometimes compromises which are hard. Especially we had that case with China and the cryptology, which we tried to standardize on a worldwide basis. So it's on that stage in diplomatic ambition almost. And coming now to the implementation part. Implementation means you have also to collaborate. Like in standards, you have to collaborate with the different parts of the value chain. And the industry, which Siemens is addressing, is for us a very, I would say, slow industry. The adoption of new technology requires a lot of testing, and safety and security have to be sometimes balanced. You can sometimes live with an unsecure system or compromised system, but you have to have still the safety in place. That means you have to think about long-term, about recovery of systems and life cycle management. And this is where we are focusing on life cycle management of endpoints in IoT and communicating, obviously, with the cloud service ultimately. And with that one, give over to Kurt.
Thank you very much. Hello, everyone. I'm Kurt Romer, Chief Security Strategist with Citrix. And I firmly believe that the Internet of Things is going to be our biggest security challenge yet. In fact, I believe securing the Internet of Things is going to make cloud security look easy. Why do I say that? It's not about securing the things themselves. As we heard from many of the other panelists, we've been securing things for decades. We know how to do that. At least we think we know how to do that. We don't know how to keep up with it, but we know how to do that, right? Where the challenge comes in with the Internet of Things is not the things themselves, it's in the use cases and everything that we can do with them. And although we've been strongly cautioned to stay away from the consumer side of things and talk just about the industrial Internet of Things, I'm going to break that rule for a second, because the interactivity is really what's mattering here. It's the connectedness of all of these devices. If you have somebody who's in a factory who is responsible for a service and a machine and interfacing with the industrial side, they are authenticating with the devices that they bring in, so that workplace knows what this individual is, knows that they're them. It might also be monitoring their vitals, knowing that this person has high blood pressure at that point in time, has low blood sugar, has a low heartbeat and a high temperature. They're sick. They obviously should not be running a very critical piece of infrastructure at that point in time. It's that type of use case that I think is really going to open up our ability to utilize the Internet of Things, but it's that interactivity that also opens up, as we've heard, a lot of privacy issues, security issues, but more importantly, safety issues. We definitely agree there.
Good, thanks, Kurt. I mean, I think I will take a thread from what you were saying in terms of use cases, and I agree that there is some level of connectivity with the user, the man, the simple man who cannot differentiate between manufacturing and the enterprise side. So what do you believe is how do you alleviate? Do you see fear in adoption, and how do you alleviate the fear on mobility and cloud, which apparently Citrix is focusing a lot on infrastructure and providing what I would say the platform infrastructure for the industrial Internet of Things. How do you alleviate this fear and concerns? Yeah, do you find it's a problem?
Fear definitely is a problem. There's a lot of us that fear that our information can be used against us or be used very inappropriately. It's not so much about security, it's about appropriateness. And we share information with healthcare providers, we share information with insurance companies, we share information with our businesses and with each other so that we can hopefully live better and we can hopefully have more information that helps us do our job better and improve the world. However, the fear comes in when that information is used in ways that we never intended, or our devices are accessed to leverage that information and use it against us and our friends and our connections and everything we're doing. That's the real security challenge with the Internet of Things. It's not just about the devices, it's about all of the things that those devices are hyper-connected to. That's where the fear comes in, and that's where we can help people understand the use cases and scope down some of our security concerns so that they're put into terms that people are actually working with every day. We're thinking about the good, the bad, and we're helping educate people for how they can set up boundaries so that they can keep the Internet of Things as their friend and not as their enemy.
And Donna, do you see this fear element as an impediment in adoption? Because you are not prescriptive, as we understand, but do you find this as an impediment in adoption?
I usually am a little bit different than most of the USG government speakers who stand up and talk about this subject. I think that this is great opportunities. Tremendous innovation is taking place today. We're going to see a very different world 5 years from now than we see today, with tremendous opportunities. And I do think that we have a lot of challenges in the cybersecurity and in the privacy space and in the safety space to bring all of these together. But as we think about some of the capabilities that will be here within the next 5 years for our health, for our communications, for our transportation, etc., there's just a wealth of changes that we're going to see that impact our lives and how we live our lives every day. You know, when you think about, in the United States, it's a big deal when you turn 16 years of age because in most places you can get your driver's license. And that driver's license used to represent a lot of freedom for, you know, you could do things without your family or your mother or your father driving you around. And now they're seeing a big shift where kids turn 16 and they are not interested in their driver's license. Why? Because they have transportation on demand. They can get there. So these are cultural shifts that we are seeing. And that's just a small aspect, but you know, when we think about the factory worker that may have high blood pressure and that person being in on the factory floor that day, yes, all of those things can come together, but the notion that before that high blood pressure causes a significant problem, we'll know about it because of the kinds of capabilities that we're seeing. The challenge in cybersecurity is being able to keep up with that pace of change and to be able to think about how to build security into these capabilities instead of what we did in the world of information technology, where we used to try to bolt it on and still sometimes do after the fact. So I see lots of innovation and opportunity.
That's good. So when with this topic about built-in versus bolted-in, I guess Brian is eagerly looking at that because I think it's one of the favorite topics that Brian touches upon. I would like to know from you, Brian, about you advocate a lot about embedded security in IoT, and maybe it would be useful for the audience for you to first give a perspective of what kind of technologies are there today, and what do you mean by, really by embedded IoT, and is it foolproof? Because there's also a fallacy that yes, you protect an equipment at source and then you're done.
Yeah, so I'll go back to what I said before. There are no silver bullets. There's no one thing that you can build in and be done. When we talk about protecting communications, we really recommend in-factory provisioning of the crypto credentials. When that device leaves the factory, it has crypto built in, it has host-based protection built in, it has an over-the-air management capability built in, and it's streaming security telemetry back to some sort of security operations center that can watch these millions and tens of millions of devices for those advanced threats. And unless you build in all 4 pieces of security, you're eventually going to face an adversary that's going to outgame you. And I applaud leaders like Elon Musk and Tesla, who have built in over-the-air update for their vehicles, and they can dynamically update the security for their cars. I look forward to more and more automakers following that lead. I think that will literally save lives. We saw the attacks over the course of last summer. Proof of concept video demonstrations of how to remotely hack a car and run it off the road. The reality is the people who did that, if they had the will, if they had the desire, they could have done it literally to millions of vehicles, crashed more than 50,000 all at once, because rush hour, single maker, that's how many are on the road at a given time. Fortunately, that wasn't their desire, but all of the cyber terrorists and organized crime who might want to impact a stock price by doing something like that, they are definitely watching. And so I think we have a limited window to get security built in, because if it's not built in, it cannot be bolted on effectively. And I think that's one of the fundamental shifts as we're moving forward.
So I think our audience also will have they may want to understand that there are billions of devices already on site. Stop. What happens to them?
So I would echo the comment earlier, a sort of rate of change for a lot of these highly regulated and large capital expense type industries. For industrial equipment, the average is 19 years is the average life cycle of some of that equipment. So you can't go through and rip and replace those devices immediately. It turns out that a lot of those devices can be still updated by the company who sold it to you. So working with them, by working with a number of the leading industrial robotics, number of leading industrial automation companies, we and our competitors are helping many of them build security into these devices that they'd already sold. Another mitigation strategy is to lay in gateways to protect these devices. But we've already seen attacks go straight to those gateways designed to protect the operational network from the IT network. The blast furnace, I mean, something so durable as a steel mill blast furnace in Germany was damaged by an attack that came through the IT network and then through a gateway designed to protect the operational network from the IT network. So these gateways are mitigation strategies, but they're not as effective as building security directly into the devices themselves.
Yes. I really believe we are far away from building security. And, if you see if you buy a car, we will offer already seat belts and airbags, safety included. And however, if I buy a computer, we have to install firewall solution and anti-malware solution. And what we really need is IT security embedded in IT solutions so that the user can't make a mistake. I never would build up an airbag in my car on my own. And that's stupid. So we are far away from what we really want.
I agree. I mean, we're very proud to say that we've helped embed security into over 1 billion devices, and this one is 1.5 billion devices. But the reality is, that's just a drop in the bucket compared to the 20 billion connected devices that we're going to have, that the industry is going to have within the next few years. This is just the early days, and we've got a long way to go. I love the analogy of the car, by the way, in terms of all of the security that needs to get built into a car. If you think about where safety engineering was 50 years ago, and where it's come since then, seatbelts, anti-lock brake systems, crash detection, airbags, rollover structures. It's not one thing that delivers safety for a vehicle. It's a combination of crucial ingredients that have brought the fatality rate down for accidents down to less than 3 out of 1,000. So if we can get security to where safety is, we'll be doing great. But it'll take us.
The question with that too is, how do you keep up with it? How does it become adaptive? Using the car example, you can go back and you can retrofit your 1930 or 1940s car with seatbelts and airbags and all these advanced systems, but do most people do it? Do they need to do it? From critical infrastructure perspective, we absolutely have to have this infrastructure be adaptive. And it's not enough to just have security built in. As Jörg mentioned, it has to be there for the entire life cycle. Otherwise, you buy a device today, and 3 years from now, the manufacturer got bought and sold 6 different times. There's no longer support. In fact, I have a phone that I just had to give to somebody because I can't use it to protect critical data anymore. That phone was only 3 years old. It's from a major manufacturer. I could not apply patches to it to keep it updated anymore. The Internet of Things is going to make that even more interesting because it's not just the devices, but it's all the services that those devices are connected to. So don't think about this as just securing a device or securing something one time by building security in. It's about being adaptive and making sure that we're keeping up with these use cases.
So, I would now throw a question to Jörg. Now, we are not talking about probably technologies and infrastructure, so there are 2 dimensions that seem to be wanting to interplay to make it work. So from your experiences with customers involved in future manufacturing, I presume you have customers who are engaged in future manufacturing, what kind of use cases are coming from them? And how have you responded to that?
So they really want integration, and it starts actually with the network and goes all the way down to the end node. And we have a little nice demo on the floor together with Cisco, where you cannot do the Ocean 11 attack, where you basically have a vault which is seemed to be closed. So, but you have to really start with the network architecture, and this goes back really to the standards work back now since '98, and I see now in this year where really the pieces are getting together, where and therefore I'm a little bit more optimistic and follow Donna's view. The network providers, they really get it now. It's getting built in from the beginning, and that's for me a positive start. And you can build it then down to the end node. And with that, I give back to you.
And just to close the loop on this from Kurt, how do you relate a practical use case probably which the audience can understand on the infrastructure playing with this endpoint security, or what you can call the embedded security? I mean, how does this play work and evolve?
From the Internet of Things, because the chain of all of the devices and services involved, each has its unique view of security and its unique view of privacy and safety. They can all communicate and collaborate to give us a view of security that we otherwise wouldn't have had. Today, you have an administrator that has to go through and verify, sometimes at a very deep level, to see if a certain patch is there for something critical like OpenSSL, which has had many vulnerabilities over the last year, unfortunately. And is absolutely essential to have that up to date and patched so that you can securely send information over networks. Today, just one person missing out on that can compromise an entire infrastructure. What if the Internet of Things was constantly being programmed to look for those security issues and vulnerabilities, to validate trust, and to not just look at itself as one piece of the chain, but actually taking a look at multiple aspects of the chain and validating those so that we have a much stronger view of end-to-end security, and it's not just based on a device.
Good, thanks. Now let me go across the ocean to Norbert a little bit in terms of what Teletas Trust represents, and could you give us some insights about which areas are of focus now with the community that you're representing in terms of technological innovations and products?
Yeah. Okay. From the Telepass point of view, if you face the fact, it's of course the US companies are the real market leader in the IT, and in Germany, okay, of course we have SAP and we have Siemens. But the IT, it's more SME-oriented companies between 10 and maybe 500 people. And in Germany, it's really necessary that these small companies have to work together. So we need standards so that the technology can work together. And that's one part. And the other part is, after Snowden and with all the NSA information, the trust in the US technology is damaged. We have to face this, and there's some initiative, one we call IT Security Made in Germany, and we say, okay, for some parts it makes sense that we use also IT security technology from German. So not for every IT, and we have a protection class development, and we say maybe for the more critical parts, it's maybe 1/4 of the IT systems that the big companies use. It makes sense that you try to replace some IT security technology. One good example is the Microsoft operating system uses BitLocker for the disk encryption, and that's an open interface, and it's not very difficult to exchange the BitLocker technology with German technology. So German technology encrypts the disk, and it makes it more secure. And I think that is maybe a good approach, and we are still trying to convince the American companies to help and say, okay, please offer open interfaces so that we can, for some parts, exchange the technology. And then we have the IT security, what we believe is necessary for the good protection of some companies in Germany.
Yeah, so I mean, just as a sequel, it's a little bit provocative. I did warn you a little bit on this. The fact is, the Made in Germany attribute for designed and made in Germany to avoid the backdoor entry, as we call it. Now, is this a practical standpoint? I mean, when you look at all companies being global, at least who are making technologies and evolving technologies, how practical is it to be that way? I mean, I think you partly addressed it by collaboration or having selective technologies speak, but how do you see it going forward? How practical it is? And I think I want later Donna's comment on this, because this is a crucial topic I presume even the audience wants to understand. Technologies are global, companies are global, problem is global. How local can requirement or standards get?
Okay, you have to see the reason why we do that is damage of trust. So, and it's a compromise, and maybe it's not what we want in the future, but it's a compromise, and it works, and it helped us to find a solution for the different kind of how secure systems should be. And if you see all the studies, the American have other requirements on security and on privacy, and in Germany we have much more requirement on privacy, and we have laws, and we have to fulfill the laws, and that's absolutely necessary to do it. I think it's not what we really want, but it's a practical solution which works in the meantime, and hopefully we will build up trust enough so that we can work much more international, and it's a compromise.
Donna, your perspectives on this topic?
Sure. So, first of all, I want to go back to the build it in versus bolted on kind of discussion. And NIST has been working with a number of international standards bodies, and we have a new best practice coming out on security engineering and how you get those requirements in. And in my mind, this is an important document because it gives people thoughts who are producing about how to engineer security in. But equally importantly, it gives consumers, other organizations, an understanding of what those requirements can be and how to ask for them. So as we go back with the automobile example, and we think about safety in automobiles, I know that a car that I bought about 10 years ago, I specifically bought it because of the safety features that it had as compared with many other automobiles at that time. So from the consumer side, we have to continue to educate consumers so that they're asking for these things. And that's how we get that kind of marketplace. In addition to that, NIST and many organizations think about your work with trusted platforms, right? Supply chain becomes very important, and to do something by geolocation, I'm not sure if any of us took out any phone that we have today and opened it up and pulled out all the parts and pieces of the phone, we would truly have a very international phone, even though we look at that phone and it has a trademark, it came from this company and we associate this company with this particular nation perhaps. But as we think about supply chain in the IT space, in the Internet of Things space, it's really a lot of components from a lot of different places. So we have to be able to build trust from the very hardware level, some of the great work that you're doing there, all the way up to the software level where we have more confidence in quality of software, and so that we can have these stronger and more secure systems.
So just one more sequel to this, Donna. What if you had a magic wand? What more do you want to be done to make all this happen?
I think that the whole spirit of collaboration is critically important, and it's collaboration between different sectors in different organizations. When we worked on the framework for improving critical infrastructure cybersecurity, one of the interesting pieces that came out for a lot of the different sectors was the interdependencies that occurred between these different sectors. And recognizing that, and recognizing that we all need to work together to make some of these cybersecurity capabilities and get them in place across the life cycle, not just where they're built in, but where they're managed, and at the end of their life cycle they are pulled out. requires us all to work together, and that's something that's really important to NIST in all of our work, that we have that kind of collaboration, and it's not just from a national perspective, but it really is from an international perspective.
Thank you. So, staying on the same topic, Brian, how, I think I'll also open it as a hot potato to the other technology vendors here. How do you see this in terms of this being a global company and having to work with, I wouldn't say having work with this constraints on regional needs to develop and create something regionally to avoid this backdoor? Do you face this problem, and how do you address this, if you can share?
So, I mean, the one irony that I would point out in this discussion is that I think just this week, the European Union and the US government just sort of forged a new model of data management for safe harbor, was the old term. And at the same time, certain manufacturers of certain devices are already under pressure to put in more backdoors, which would run contrary to a lot of what the rest of the international constituency wants. So it's a mess, and I mean my hope is that Washington makes decisions that repair that trust that has been damaged. That would be my core hope.
And what would be your perspective, Jörg, on the same topic?
We are building crypto parts, so we are obviously on the radar. But with the crypto which we build in, which is commercial crypto, and the interfaces are limited from a bulk encryption perspective, we are basically can deliver this with certain exceptions around the world. So we have, as a semiconductor and software provider, we have to have a global market. If you would limit this down to every country, it would not scale. It would be too expensive. You do not have interoperability. It's not a model which we would support.
So again, using the magic wand, if you had something that you would like to ask, forums like Teletrust and NIST, what would be your, request to them?
Let's get the standards faster out.
So,
is that set by side? What I would like to request is on very basic technologies that we get their kind of roadmap. This is for crypto. This is for these really fundamental technologies where we as a company do not do the research, but where the standard organizations of utmost importance.
could you give a quick comment on that from either side? Do you believe this is something that's feasible and practical in the short term? That basic technological developments will happen from the government side?
I think standards.
Standards,
So you said,
standards.
right, and standards should be a body where everybody has the opportunity to be able to participate.
And is this something that you see as possible across geography?
Me?
Yeah.
Yes, I do. We had we at NIST really believe in that global model, particularly when you look at something like the challenges to build strong cryptography and the kinds of analysis that need to occur. So as we're looking ahead at something like quantum resistant cryptography and some of the good work that ETSI is doing, and being able to work jointly with them and with individual nations as they look and understand what their requirements are, to be able to publish these and have those kinds of conversations as we're looking to to develop those necessary standards is very important to us. That's the reason. Sometimes it doesn't go as fast as you would like, because when you have that opportunity to get feedback, to get input, to be able to work these jointly, it does take more time than if you were just to say, here's the answer, I'm going to put it on the table. But the outcomes of what you're looking for in something like strong crypto standards is that international collaboration. That's what makes them the quality that we end up with. So in the United States, the Advanced Encryption Standard and SHA-3 are actually algorithms from Belgium. That's a good thing for all of us. It provides the security and security analysis that have been done on those, as well as the interoperability.
And Norbert, I mean, coming to the perspective from a German industry perspective and what the companies that are associated with Teletrust are developing. So on one side, could you give us some insights of what has been the largest asks from the market, the industry, the market that you are addressing in Germany, and what have been the clear areas that the companies that are associated with Teletrust are focusing on in cyber? And maybe the last part of it is, okay, what would you expect from the collaboration with the large organizations that are based on the US and the statutory bodies, making your initiative much move faster?
Yeah, if we put all things together and see what are the real challenges we have in Germany, of course, first we have the privacy challenge, and it's a different point. Then we have industrial espionage is a big problem for the big companies, and they really know that a lot of things are happening, and they try to find good solution. How can we protect us in the right way? And I think in the future more cyber law issues will coming up, and here we have the anti-security law in Germany since last September. If you see or if you following all what you are saying, it's our targets. So we want to be and have to be, and if we hear the discussion in Washington, it's another language, and we really have to understand how can we come together. I think in theory it's a wonderful idea to have standards and work together, but in practice we have to build up trust, and we have to trust Washington that they don't get out with some requirements for the US company which we don't like. So that's one issue. And if you see from the German point of view, what we really need is we try to push the encryption, more encryption with email or chat systems, or what we also like, we would like to have better IT security architectures for the end devices, microkernels with virtualization and separation technology. That is what our companies, or some of our companies at Teletrust try to establish, and so maybe that are the biggest movement we see. And we have a lot of other ideas with all together as a company, but I think it's still a hard work to convince the big companies to spend a lot of money to introduce all this technology which we already have.
So, I mean, it's again, the languages in Washington and Berlin are different in terms of, for example, in Germany it's a law, and cyber law, and here I think Donna speaks about a framework. A framework is not prescriptive, it's more difficult. So how effective has been the law? Because it must be, technically speaking, shouldn't it drive more adoption as compared to US, which only has a framework which is not prescriptive? Yeah. And maybe Donna, you can comment on your challenges on that, but I would like to hear from you.
Okay, since last September we have an IT security law, and the Federal Ministry of Interior is trying to higher the IT security level with this law, especially in the field of critical infrastructure. And I think the general principle of this IT security law is that they give a framework for trusting cooperation with all the stakeholders. And I think the two most important aspects is first the obligation to maintain minimum IT security standards for the operators of critical infrastructure. And with the help of the definition of a minimum standards, the government can control the level of IT security in the long term. And the second important part of the IT security law is reporting important incident to the Federal Office of Information Security. And with the reporting of incidents, the government is able to build up an IT security awareness picture. And this awareness picture will help to identify the most important threats, and we can faster react with counter mechanism. And I think both aspects are very helpful. And all the stakeholders are busy to implement the IT Security Act. And I personally believe it's the right step to hire the IT security trust in Germany.
And Donna, you hear the perspectives from a law framework, and maybe now it's on how effective has been the framework itself.
So the framework for improving critical infrastructure cybersecurity that we worked on very closely with industry and academia and other U.S. federal agencies, and actually really internationally, because parts of the framework have been adopted in a number of other nations. One of our colleagues was speaking at a panel about 3 weeks ago where Italy has taken a large part of that framework and incorporated it into some of their work. So just as one example, but the notion that cybersecurity is going to evolve was something that was really important to us as we developed the framework. If we look at all the great work that many of the companies that are up on this stage are doing today and have been doing over the last 5 years and 10 years in terms of research and new capabilities, and ensuring that those kinds of capabilities and many national governments have put in with their research organizations, and bringing that to bear into a commercial marketplace so that we can take advantage of those new technologies, that we can address the threats that are here today and those that will evolve tomorrow. We believe that the framework, by being voluntary, would allow for that kind of evolution to occur. And we're actually hosting a workshop April, I want to say it's 6th and 7th, but I may have the dates wrong. And looking back at the framework, which had a birthday in February, so it's 2 years old, to understand what needed to be changed. We put out requests for information, what works, what might need to be changed. We asked questions about the conformity aspect, which I think is an important piece of setting something up, and different ways that you can look at conformity assessment to the framework so that you can understand the cybersecurity posture of different organizations that you are depending on, and how to do that in a way that's meaningful is a very hard question. And how do you create that environment so that it's not just somebody checking boxes? So I think that'll be an important conversation at the upcoming workshop that we're hosting on the framework.
Thank you.
I'd also want to correct the notion that everything in the U.S. is entirely voluntary. I think NIST focuses on getting the standards right, and then in each vertical, FDA for medical devices, NHTSA for vehicles, NERC for energy. Those agencies come along and decide sort of the right level of regulatory enforcement for those standards and adoption.
Right.
So I think that's a middle ground, and we can each have our opinions on whether the middle should shift more toward the European model or not.
Yeah. So before I throw it open to the audience for questions, I will say 30 seconds for each panelist to say okay, we've spoken a lot about what is and what was. What is coming? I mean, maybe starting with you, Kurt. What is coming in terms of technology in the next 5 years in this space?
Really what's coming is going to be a lot more interoperability and a lot of things we haven't even thought of right now. We need to be prepared for a lot of change in the space and a lot of innovation and be able to have a framework that we rely on. NIST does a great job putting that together that can then be leveraged to build these future models and build these models so that they do interoperate securely. That's what's going to be important.
Yeah.
From my perspective, we will be in 5 years at a stage that no passwords are any longer needed, because we make FIDO a reality. And the latest Cyber National Action Plan from Obama announced on the 9th of February exactly directs mutual authentication. And it's, I would say, can be marriage and heaven.
I'm worried that we're going to see a lot more attacks and attacks with higher consequences. What we've really seen over the course of the last 12 to 24 months have really just been the shots across the bow in terms of energy, medical, manufacturing, vehicle. And the risk is very clear, and I'm worried about the adversaries out there, the sophisticated adversaries that might want to achieve large-scale consequences with them. So that's my deepest concern.
And I know you don't want to give your roadmap, but what is coming from Symantec in the next?
From us. So we've when we say we've embedded security into over 1 billion devices. That's both on the authentication credential side and keeping the device secure. That ability to look for seriously sophisticated adversaries that overcome those first 3 cornerstones and including sort of keeping up with the update. So anomaly detection, this security analytics specifically for IoT is what's in beta right now. And if you're interested, stop by the booth or shoot me an email.
Thanks. So now coming to the to Rona and Norbert, what do you think is, from your perspective, going to be the top priorities in the next 5 years?
The top priorities in the cybersecurity arena?
Yeah, in the
So I think the internet, the interconnectivity, and I think our reliance on networks, and the whole notion of how do we really get to resiliency across these environments, because we won't be able to stop every attack, but in fact we can be more resilient, so we can isolate those, and we can get to the point where we can recover much faster. We're actually having a session to talk about recovery, which is one of the elements of the cybersecurity framework: identify, protect, detect, respond, and recover. And there's a lot of standards to help you identify your assets and to protect them. Lots of good work in detect and respond. But many organizations have come to us and said, we probably haven't put as much into recovery. And when you think about your concerns about recovery, is it at the system level, at the organization level, or beyond? And I think that's something we all collectively need to work on.
Yeah, I think the digitalization process is getting faster and faster, and we have really to understand that we have a big problem at the moment. And I joined the college from Symantec. Every hacker can hack every computer, so we have to see this, and so we need really a hard change, and we have to do a lot to make our future more secure. And if I see what we need in the industrial internet, I think we believe verification of identities, the definition of identities and of things, and also what are authentication method. We need also security infrastructure services for authentication, encryption, which we all can trust. And we need modern and secure trust-based operation systems, which offers also security functions for distributed communication and services in the Internet of Things. And of course, we need much more concepts for protecting the privacy, and also we have to think about how can we protect self-determination. I think that's also a big issue in the future.
Thanks. So I think it's all about trust and opportunity. I throw open to the audience for questions. So could kindly tell from, yeah? I think the gentleman.
Great panel. I thought it was really good information. So I'm with IOActive. They were responsible for that, the GPAC last year. A couple of things were mentioned that I thought were really interesting. One was the transition between regular IoT and the industrial side. And one of the things we think about is sort of cascading failure, and where you can have a transition that you wouldn't assume could happen. So for example, let's say there's a low vulnerability where attackers can change the password, right, from the internet. And this is a very low vulnerability, and people are like, well, that's not critical. But maybe an attacker would say, let's do this for millions of homes at the same time in order to put a load on an industrial system, which then fails and then cascades. So do you think enough is being done to sort of look at dependencies and where a failure happens, where we move?
No, I think dependencies and assumptions are areas that need more attention. Another example related to something as simple as a thermostat is we've actually seen building enterprise networks which are fortified, from a firewall perspective, actually infected through HVAC, through high volume AC systems and other building management systems. And so these dependencies, manufacturing has a huge dependency on energy, for instance, but a lot of the dependencies are a lot subtler. And so when organizations sort of go through the first step of good security engineering, in my mind, is threat modeling. And they really need to look at all of those dependencies and assumptions very, very carefully, because adversaries love to do damage to those.
Ronald Noel from ITIL speaking. What I was missing from the panel is we have the threats today, Norbert put that out, but we have no mechanism in preventing IoT from overstepping the red line. And let me explain what I mean with that. We are all here, IT security, in preventing people from access to data, but the lives are at risk within IoT. And I think we are still talking. Donna, you put forward that we need to have discussions about what is really important, availability, is it confidential, do we really need privacy? We have the threat that lives are at risk at the moment you put IoT live on the internet. And I think that we don't have any mechanism up now to prevent from overstepping that red line. And Donna, you said we should talk like business. Let me give you the experience of the last 20 years of talking business. There is a great opportunity in cutting down the costs by using IoT. And everybody is willing to cut down the costs. But no one is willing to take the costs for implementing better security on that. So Norbert said that in Germany we do have a law which was put out last year, and I think that this is one step in the right direction, because speeding is, everybody knows about the speed limits, and everybody would go faster if there wouldn't be tickets for speeding. So if you don't have any law enforcement, well, it doesn't help. And so I was looking forward, is there any mechanism in place that keeps all the people, all the stakeholders from overstep the red line, which is put the lives at risk?
So I'd like to challenge you a little bit back with that, if I may. When we first started with the framework for improving critical infrastructure cybersecurity, there were some statistics that less than 10% of boardrooms were asking questions about cybersecurity. And when the framework came out, it was somewhere around 46%. And there are some reports, I'm not an expert, I haven't gone out and verified these numbers, but I can point you to where they're coming from, where in the United States, 86% of boardrooms today are talking about cybersecurity as a critical function for their organization.